that he has the attitude of fighter. There were many saints and sages and all, but nobody had such youthfulness. Nobody had such energy and fighting nature. That's why he's called Yoddha Sannyasi. So he was a sannyasi, no doubt. He had a spiritual realization of the highest order, but his attitude was attitude of fighting for the truth. He could stand for the truth. And this is a quote from Sri Aurobindo when he was asked about another great sage of modern India. He was asked, his answer was, the attitude of a fighter who was a representative of something very great could not allow himself to be put down or deleted. He could not allow himself to be put down because he knew he is standing for something very high. And that's how we'll see his journey. Next. So Swamiji took the battle to the pitch of the Western intelligentsia. The pitch, he made the impression. That's why he chose America, the land of science, and he talked from that pitch to proclaim the glory of Vedanta. This is something very unique. During his stay in America, he met some of the greatest scientists. You must be knowing Nicholas Tesla and many other people who were influenced by his thoughts. So in the land of science, he proclaimed the glory of Vedanta. Next. So to understand what he has done, let us go back a few steps and understand what exactly is science. So science basically is a dispassionate inquiry into truth. To make something very, determinist, to understand that something is going to happen, that means something is definitely going to happen. And if I do something in my lab in one point of the earth, it should be repeatable to all the other points on the earth. That's the glory of science. Its power of getting generalized from an experiment which is done at one point. So that is what science is, a search for truth. And it all starts with Copernicus, Kepler and Francis Bacon and all in the 14th, 15th century. We all know till 16th century this continued. And they challenged the fundamental religion and the faith which was telling people not to think. Don't think anything. I'm not asked you, but this English is okay? What I'm saying is okay? Okay. So he said that, at that point of time, people were generally told that this is written in some book, this is said by some great person, some holy person, and therefore you have to follow it. Common people cannot think about why and what. They have to simply follow it. And in that age of blind faith, science came as a rescuer. In the human cycle of mankind, this was the age of reason. And therefore, people started asking questions. First time somebody said, why earth is flat? My experiment says earth is round. Or why you think that earth is the center of the universe? The whole idea of homocentrism was challenged by the scientists which is coming here, and they said that earth is neither center of the universe nor it is flat. It is one of the planet and it is revolving around the sun, and there are so many other galaxies where other suns are there for their planets. And you know how they were tortured, they were imprisoned, they had to face so many threats to their life, but these people, the real passionate people for the truth, they continued on their journey of finding what exactly was the real thing, not something written in book. And therefore there were, use of telescopes, and then there was Galileo's experiment of falling bodies. All these things have happened during that time. And then there's a famous statement by Francis Bacon. He said that nature has to be hounded in its wandering, and she should be imprisoned and tortured so that she can give all her secrets. Now this statement is very important for us to understand where science has ultimately come. Francis Bacon, one of the leading scientists, as we know, he has made this statement which is quoted by William Cowper, and he says that nature should be imprisoned, tortured, and she should be. Remember, he is calling it she because nature was believed to be feminine in most of the cultures. And she should be forced to give up her secrets so that humanity can use those secrets and make something usable, something which can give us more and more comforts and luxuries. So that is how the passion for truth, the search for truth, ultimately become something which can help us to get more and more comforts. This is a transition which is very subtle but very important. And when he is telling that she should be tortured to give up her secrets, he is comparing nature with a feminine spirit. And the witch hunting tradition which was prevailing in Europe was just simulated to understand, as we can find out from witch hunting or torturing the witches, so-called witches, find out the secrets about the mystic world. Similarly, we can torture nature and find out secrets about the natural world. So Francis Bacon's statement, taken forward by Descartes, who we all know has done a very fundamental, great thought he has brought about, that I can because I think I can. And then Descartes had this idea about trying to find out where this matter and spirit, this eternal problem can be resolved. So he was looking into that. But ultimately with Descartesian, Newtonian and all these philosophies, there was a philosophy of science which came out, which was strictly determinist. It was considering world as a giant machine and fixed cause and effect rules. And these cause and effect rules are ultimately going to give us all the secrets of it, which we can use for our own benefit. So this is the Descartesian or Newtonian philosophy. Next. Michael Faraday, as we all know, how this progressed. This went on progressing for quite some time till there was a challenge posed by electromagnetism. And we all know Michael Faraday and all these people, they have done fundamental work to prove that electricity is not just a force, but it is a force field. It is a field around the force. And when they started saying this, there was a big challenge to the determinist philosophy, because if there is something like a field which is not directly found out by our senses, but it is existing, then how to qualify this particular statement that we will have science only for those areas which we can see, we can hear and can touch. That was celebrated statement of Galileo when he said that science should limit itself only to shapes, sizes, touch, sight, hearing and on. It has got nothing to do with feelings, it has got nothing to do with the sensations, it has got nothing to do with what it will be if I am there. That experiential factor which now artificial intelligence has brought back again in the terms of qualia experiments. If somebody has read about that, qualia is the biggest challenge for artificial intelligence for quite some time. Because qualia speaks about experiencing something. Thomas Nagel said, what it is to be like a bat, I will know only when I become a bat. Till that time, I am only talking about the echolocation. I know there is a science of echolocation that bat will send the signals and they will reverse back and all. I know that. But that doesn't make me understand what is it to be a bat. So this experiential factor which Galileo had excluded, Thomas Nagel was forced to bring it back, especially because there was a progress in the field of artificial intelligence. So very interesting turn science has taken over the period of time. So, but starting was Faraday, as I said. So Faraday was talking about electromagnetic waves and fields and all, which first of all challenged. In fact, when Newton said that there is a gravitational force trying to attract the bodies in the cosmos, many people were startled, because that means nothing but something mystic. You are trying to talk about something that action can happen at distance. If action can happen at distance, that means you are challenging the basic idea of materialist and determinist philosophy. No action can act at distance when we want everything through a material phenomenon. So within the scientists there was a big churning about what exactly is truth. Yeah, the term ether was used so many times. You must have heard in the ancient times onwards. In our literature it was akash. In western part it was ether. So ether was used everywhere. But ultimately, as the scientists started doing experiments again and again, they found we are attributing properties to ether which are contradicting each other. For example, to make it simplified, one says ether is very light, second says through his experiments ether is very heavy, third says ether has got a smell, fourth says ether has got no smell. So everything is ether, but everything has got contradictory properties. So the question came, can there be any real element which can have so many contradictory properties, and then in that case how it can be real? So the whole idea of ether had to be negated by science, from which science started. They slowly started telling ether is not there. And you might be knowing now, again in the 21st century, they are starting accepting that ether is there. So within the passion of truth, within the dispassionate search for truth, we have still lot of contradictions still not resolved. And then we have got Pierre-Simon Laplace, one of the biggest person in the field of science, and Kant, Immanuel Kant, in the field of philosophy. They both first forwarded the concept of evolution. It was before Lamarck and Darwin. So Kant put it in the field of the philosophy, and the Laplace put it in the field again of philosophy, and thought that there can be something like evolution. Again contradicting the age-old tradition that God on a particular day thought that there can be a world, and then two amoebas, two giraffes, two lizards, two human beings, all were sent to the earth so that there can be happy life here. No, that's not the case. We have evolved from something which was inconscient to the process of a single cell amoeba, or something what we call it single cell species, and then from that slowly it became to something can be in the water, something which can be reptiles, something which can be still growing up and becoming birds, and that is what the evolution is all about. So Lamarck and Kant first made a serious challenged this age-old idea, and which was taken forward next by, of course, Lamarck and Darwin. So Lamarck we don't know much, but Darwin we all know. And he went to the Galapagos Islands and he saw all the animals, and then he started writing about that. And he simply reversed the entire cycle of creation, that there has to be creation from down to the up, which has again posed serious challenges to the ancient traditions, books and philosophies and all this. If it has all started from bottom, first of all, who went to that bottom to do that? And then what happens to my holy book, which is writing not that, something different. So there was again a tussle in that. And we all know about Laplace. See, but the beauty of all these things is that scientists themselves, I will give 3 examples. Laplace, Newton, Laplace and Einstein to begin with, and Newton also. And they being scientists, they were trying to find out something which can challenge the so-called religion and traditions, but they themselves were part of that tradition. Therefore, they, after their own findings, they were very perplexed and they were saying, no, this is not true. I found it out, but this may not be true. Look at what happened to Laplace. During those days, there was a tradition that they should be presenting their books after they write their thesis and all. It should be taken to the king or the emperor, and the emperor will put his note on that, yes, done, and then it will be ultimately going to the public. That was a normal case. Now also we have to go to government and get it. But that time they were going to emperors. So Laplace went to the emperor of his area, Napoleon, and he gave his book to him, the thesis to him. And Napoleon turned the pages anxiously, because during those times, till that time, it was a tradition that you have to put somewhere, it should be mentioned in your, you are thanking people that I have written this because of the purpose of this, So in that there was a mention that because of grace of God, because of God's all blessings, this work has come. Somewhere it should be mentioned, because till that time, philosophia or principia and the science was not away from each other. Philosophy was one with the science, search for God was one with search for material truth. But then it was challenged with Laplace and other people. When Napoleon was turning the pages and trying to find out where exactly is the mention of God, he found nowhere. He had beautiful mathematics all over, science everywhere, but there was no mention that this is because of God's grace, blessing, this, that and whatnot. Or I surrender my efforts at the feet of the Lord, nothing like that. Not even surrender at the feet of the emperor, that also is not there. But he could not tell that directly. But he said, God is not there, something wrong. You make this correction, bring it back, make the correction. So Laplace said, sir, and that's a epoch-making sentence, how science turned and became something different. Laplace told Napoleon, sir, the hypothesis of God is not necessary to prove my thesis. You are all sorts of science, right? There is hypothesis to prove some thesis. And Laplace made this great statement, great from the science point of view. Nothing wrong with that. He said, I have made a thesis, I have taken a hypothesis, but hypothesis of God is not necessary to prove my thesis. I can prove it without that. So God does not exist. How can there be a God which is just sitting all above the world? He has created it for no reason, and when the world is in turmoil, when all of us are suffering, He is there, enjoying. I do not want that God. If He is not part of this world, I do not want Him. He cannot interfere and stop the nonsense here. If He cannot stop the cruel people from doing the cruelty, if He cannot support the weak people when they are getting suffered, if God cannot do that, that hypothesis is not necessary for me when I am doing something for the well-being and development of people. That is the undercut. I don't want that. And Napoleon was stuck. He said, okay, what I can say now? You have made this. You go ahead, because it seems useful. Because all this scientific development was useful for spreading colonizations, emperors, powers were spread because of that. So he wanted that. So he said, okay, that's a new thing. Good. So, and this story or this episode you can see in Stephen Hawking's book, The Brief History of Time, who is well known as one of the greatest scientists of our times. He has narrated this in his book. And even I was surprised to see this, how that arrogance came, how that adamantly came. When initially, the initial scientists, when they started searching for the truth, they were thinking this is all search for truth, which is God, which is beauty, which is, it's all same. So truth is beauty, truth is piousness, and all that is God. So that was the idea before Laplace and people started talking like this. Albert Einstein, how we can forget this when we talk of science and spirituality. 1905, he took his paper, and then another paper after almost 10 years. A clerk who is working in the patent office, but he was working secretly on his findings in that same office. and ultimately shook the entire world, literally shook the world when he talked about the special theory of relativity and the general theory of relativity. He was the person who brought to the notice of people that space and time both are curved and both can be one, and there is relativity. So all these things are there. We all know about that. But in our present context, he was the one who has really started shaking the foundations of physics. And at two levels, largest of the largest, when you are astronomically going beyond the galaxies, that is one level. You are going to the largest dimension possible, crossing the galaxies. And they can be smallest of the smallest dimension. That means you are going inside the atom to the subatomic level. You are trying to find out what happens inside a neutron, electron, proton. That is what you are trying to find out. At that level also, our determinist and Newtonian science started failing. At the astronomically high levels also, it started failing. The laws which were so much cherished, so much devotedly guarded for so many last 100, 200 years by science, they ultimately started failing miserably when we went to both the extremes, highest of the highest, lowest of the lowest. So where it is true, it is only true in the middle dimension, which Gita says is Vyaktamadhyam. And many scientists then started thinking, there is a scripture like Bhagavad Gita where it is written, Avyakta Bhutani, Vyaktamadhyani Bharata, Avakta Niram Neva, Tatra Kaparitiva. So there is a middle dimension where laws are applicable, there is higher dimension they are not applicable, there is lower dimension that this is science or this is philosophy. These scientists when they started churning their minds and they were perplexed, they were totally, they were shaken, they were shattered. And these are great episodes, you can go through their ideas and their emotions and how much they were carrying that passion in them and getting baffled by the answer which nature was giving. And somebody said, can nature be as absurd as it seems to us in our atomic experiments? I think it's Heisenberg. Can nature be as absurd as it seems to us in our atomic experiments? It cannot be that absurd. Somebody else said that electrons are particles on Monday, they are waves on Tuesday, they are again particles on Wednesday, they are again waves on Thursday. What are they? Are they waves or particles? Every time I see them, every time I make an observation, they realize that they are changing their nature from particle. The famous double slit experiment and all these experiments were finally made give us this particular conclusion that they are neither waves nor particles. It all depends on where you are standing and where you are looking at. So observer's inclusion into the scientific experiment became a reality because unless you are observing something, there is nothing happening. Niels Bohr once said, these are all names we all know, Schrodinger, Niels Bohr, Heisenberg, Einstein, they were all these stalwarts of this new science. So Niels Bohr once said, does a falling tree makes noise when it falls in a forest? And the answer he gave is, the falling tree makes no noise if there is nobody to hear it. Beautiful, beautiful. The falling tree makes no noise if there is nobody to hear it. There is somebody to hear. That's why we say falling tree is making noise. And then his friend went one step further to say that not only falling tree does not make a noise, but there is no falling tree if you are not there to observe it. I repeat, not only a falling tree does not make a noise, there is no falling tree if there is nobody to see. You have to have there, you have to be there. And that's why it is something which is observing the things. The observer has to become part of the experiment to give the result of the experiment. The whole foundation of objectivity which had been so cherished by science was null and void when somebody said like this. There cannot be objectivity. There has to be subjectivity. Observer's consciousness has to become part of the experiment. Then only you will understand whether electrons are becoming particle today or they are becoming wave tomorrow. And this is a huge change. Where are we? Next. Yes, I've taken that. At both the levels they failed. And they had to think now, seriously think about the whole method they were applying for thinking on a particular issue. The whole paradigm, whole thinking by which they said that we are going to do this by these methods. This is the way we will work by experimentation. That method itself was challenged by this whole happening. Okay? So we have to understand how this whole thing has gone so deep-rooted. Atoms, electrons, protons, all these things, neutrons have become just like X and Y and Z for a child who enters school for the first day and starts learning algebra. This is a sentence for other scientists. I go to school my first day and the teacher says X plus Y equal to this and that and Y plus Z is equal to this, and I take it down. I soon understand. If I don't understand, memorize it, I will be beaten by the teacher. I will be failing in the exam. So now I carry that image that X plus Y, X square plus Y square is this and so on. But then we still don't know what is X and what is Y.